Hello and welcome to a new episode of our CDS Professional Talks. Today we want to talk about airports and there especially about AGL, Airfield Ground Lighting. That's myself, Christoph Dorscheid, I'm the Sales Director.
And me, Martin Freimuth, I'm the Export Manager.
Martin, first of all, let me ask you this question. How did it happen that CDS developed materials for such an especially field of application and sells it to the whole world today?
It's our history. CDS Polymer was a department of Possehl Spezialbau, Germany. Possehl Spezialbau was founded in 1956 as a construction company carrying out maintenance and repair works at military airports near Sprendlingen, our headquarters until today. This, of course, included installation works, inset installations. Since material at that time was often not up to the requirements of airports, Possehl began pretty soon to develop and produce own material for airports. The brand CDS was born. Since the spin-off in 2012, CDS Polymer develops and produces and delivers this material to the whole world.
Okay, that's quite a long time and a lot of experience on this field. But let's go a little bit deeper into the material now. The surfaces on runways, taxiways, and shoulders at airports are different. Some are asphalt, some are concrete. This places different demands on the products. So can this be covered by one material?
No, it can't. Therefore, CDS developed two types of material. A more rigid type called UW or UW Rapid, which is a more faster curing type, and a more flexible type, which is called UW Flex for installation in asphalt.
Okay, different types of material mean different types of installation methods?
No and yes.
Okay.
Let me explain on this sample.
Okay. So should I get the sample?
Yes, please. Clear the table.
So what do we see here?
Okay, there's an installation or fixation of a shallow base left in asphalt and on the right side into concrete. And there is a mortar bed beneath the shallow base to bear the high loads of aircrafts taking off and landing on airports. Basically, the use of the material is similar in the installation method. Yes, you pour the UW Flex into the asphalt pavement beneath the gap between the shallow base and the asphalt, and on the right side you fix the shallow base with UW, the more rigid type.
Okay.
Let me show you how flexible the Flex UW Flex is. So you can bend it with your fingers.
Let me try this.
Yes, please.
Okay, that's very flexible.
Yes, it is. But it has to be flexible because in asphalt you have movements, more movements than in concrete.
Okay.
And this material has to take these movements.
Movements caused by temperatures?
By temperatures, yeah, most of it. Yes,
Okay.
yes. And this one, the more rigid type, you can hear, you cannot bend it, it's more rigid. Okay. But basically it's the same application, the same installation. Pouring the UW or UW Flex, and beneath there is a mortar bed. The mortar bed has to have sufficient compressive strength to bear the loads of aircrafts taking off and landing. But now to the different types of installation or different kinds of different. You can use in concrete or in concrete only. UW, the rigid type, or UW rapid, and pour the whole borehole with this material only.
Okay.
So you don't need a mortar bed. You can use UW rapid. It offers very high compressive strength, and it prevents the shell from sinking.
Okay, but this is only used in concrete, right?
This is only used in concrete. For an installation in asphalt, the use of a mortar bed and UW flex is mandatory.
Okay. So the sample shows the situation after the shallow base has been fixed. So what about the underground? How has it to be prepared before the installation?
Drilled holes must be free from dust, loose stones, drilling sludge and other contaminations. Remove stagnant water. Pouring can be done on slightly moist subsurface.
Okay, so let's say the underground is perfectly prepared. So what's next?
Yeah, it's easy. You place the shallow base into the borehole and into the mortar, and you align it into the mortar bed. Or if you cast completely with UW, the rigid type, use an installation jig to place and align the base. Then you can pour.
Okay, so then everything is prepared for crowding and we can start the mixing, okay? Yes. So can you explain the mixing procedure?
Yes, I can. Could you just help me? Or
I'll take this away, all right?
Okay. Okay. UW, the rigid type, or UW flex, are always delivered in 8 kg delivery units, which is 1 can with the resin and 1 plastic bottle with the hardener. You open the can, you stir the material for about 1 or 2 minutes to remove clots, possible clots from handling or from the transport.
Yeah, okay.
Yes. Afterwards, you take the hardener, you pour it into the resin, and then you stir it for about 3 minutes. Check time with watch. Then you can pour the material.
Okay. Is there something special to pay attention to while pouring?
Yes, indeed. Pouring is very easy. But please note 2 little things. First, to avoid air bubbles, please only pour from one side or at one place. Do not circulate. And second is, make a first layer, pour the material until about 2 centimeters below the brim of the final level.
Okay.
Let the material settle and then pour to the final level.
Okay.
One moment, there is a recommendation. Pour the second layer next day.
Okay, why?
To give the material enough time to settle.
Okay.
It crawls beneath the shallow base, but this needs some time. Second layer can be poured within 24 hours without special preparation on dry, not soiled surface of the first layer. If necessary, blow away dust or stones.
Okay.
If mixing and pouring is done correct, there will be sufficient adhesion between the 2 layers.
Okay, so now if the material is used in, let me say, renovation works, I'm sure time is a critical factor.
Yes.
So runways in operation can only be closed overnight. And how long does it take until the material can be overrolled by heavy airplane traffic?
Yeah, this depends on the temperatures at site during installation and the type of material and hardener which is used. For example, if you use the type UW Rapid with the fastest hardener, you can overroll the lights within or after 2 hours at 10 degrees Celsius.
Okay.
Yeah? Hardening times at different temperatures are also shown in the technical data sheets.
Okay, so that means we offer different types of hardeners?
Yes, yes.
And with different times, or depending on temperature, we choose which hardener to take, right?
Yes, that's right. We have 2 types of hardener. One is the hardener S, which stands for summer, for higher temperatures. And then we have one FH, which is in Germany, Frühjahr, Herbst, which means autumn and fall, for lower temperatures.
Okay. Okay, I understand. So can you now tell us something about material consumption?
Yes, material consumption depends on the volume to be filled.
Okay, that's
basically the gap around the shallow base and beneath the shallow base. And, of course, the dimensions of the borehole. And the shallow base itself, if it is 8-inch or 12-inch. As a rule of thumb, you can calculate with 3 to 4 kg for an 8-inch shallow base and about 7-8 kg for a 12-inch shallow base.
Okay, that brings me to delivery units. Can you tell us something about?
Yes, I can tell you and I can show you, because this is the usual delivery unit.
Okay.
In general, we deliver most of our material in 8 kg, which means a can for component A or with component A and a plastic bottle with the hardener. Material is delivered in ready-to-use units, which means you always take 1 can of resin and you mix in 1 bottle of hardener. Do not use half a bottle of hardener or 2 hardener because you would like to have it cured faster or not so fast. This will not work. And we do also deliver in 20 kg delivery units. In larger projects, when you need a lot of material, then you can purchase 20 kg delivery units, which is less expensive, of course, but the handling is not that easy.
That's heavy to handle on the airfield. Okay, so another thing is that one can imagine that the safety requirements on airfields or on air traffic areas are very high. So the built-in material must withstand the different stress factors, right?
Yes, that's right. There are the air traffic areas are exposed to severe climatic, mechanical and chemical stresses. This places high demands on the material. Demands are described in FAA Advisory Circular 150. In item 606, the requirements for a suitable material for sealing, wire and lights in pavement are described. Our material has been tested for these properties by an internationally recognized test laboratory and meets all requirements. We have corresponding tests for our material for installing in concrete or asphalt. Furthermore, the material has been tested on resistance against all kinds of chemicals or fluids which you will find on airports, air traffic areas, which is kerosene, gasoline, diesel, brake fluid, de-icer.
Okay, that's clear. Are there any other special technical properties that you would like to mention, or what else is important?
A temperature. Temperature is always an issue, not only during the installation, but also the temperature to which the installation is exposed to. And UW is temperature resistant against temperatures up to 80 degrees Celsius long time or constantly, but up to 120 degrees Celsius short time.
Okay.
And this is important, especially on airports in high climatic regions,
Okay.
where the asphalt heats up to 100 degrees Celsius
Okay.
during the day.
Ah, okay. Yeah. Okay.
Yes. And shrinkage is an issue.
Okay.
Epoxy-based UW cures virtually shrink-free. Okay. There are other materials on the market on different chemical base which cure a little bit faster,
Okay.
but you pay the faster curing often with cracks.
Yeah, okay.
That's important.
Yeah, that's easy to understand that a faster curing leads to shrinkage, and shrinkage leads to cracks. That's easily to understand. So now you have explained the fixation of the shallow base on a sample which shows electrical cable coming from below. So how about electrical installation where the cable is laid in a cable duct from inset light to inset light? So do you have a material for filling these cable ducts?
Yes, we do. We do offer a suitable material. It's called cable joint filler. It's also a two-component epoxy-based material. It's permanent elastic because sometimes if the electrical equipment has to be removed,
Yeah.
For inspection, for example,
Yeah.
it is very important that the material offers a flexibility, so you can remove it without harming the cables.
Yeah, okay.
Mixing and pouring is similar to UW. You would not see a difference between the two materials,
yeah, okay.
but it offers a little different properties.
Yeah, okay.
It can be used in concrete and asphalt, the same material. We do not have two types of materials for asphalt and concrete, like with for the inset lights or the shallow bases.
Yeah.
But if you use it in concrete, you have to apply a primer first,
Okay.
which is also offered by CDS. Let me show you how it looks like.
Okay, should I take this away?
Yes, please.
Yeah, okay.
Thank you. Yeah, that's a sample with a cable joint filler.
Okay.
A smaller cable duct and a wider cable duct.
Yeah.
And yeah, it's nothing great to see, but you see, how it is applied.
Yeah. Okay.
And looks in concrete in this
Case. Yeah.
example. Material is also resistant to all kinds of fluids, which I already mentioned. We have test reports for this too.
Oh, okay.
Yes. Let me show you something special about this material. Especially when working at night, it happens that cable joints or cable ducts are sometimes mistaken for expansion joints.
Okay. Yeah.
So at the airport, they want to remove the material from the expansion joints, and then they remove the material from the cable ducts, which is not really nice, because then you have no lights. Yeah. So we developed colored cable joint filler, so you can easily see if it is gray or...
There's a difference between the different kinds of joints here, or cable ducts.
If it's blue, it is a cable duct, or if it's red. We sell this material to several airports. For example, in Hamburg, in Germany, they take the blue one. And
for the cable duct?
For the cable duct.
Okay, so they have a difference, and they...
and they see in first sight...
That avoids mistakes.
Yes, and damages.
Damages, yeah.
Okay.
So you mentioned that the company and the production site is located in Sprendlingen, which is near Frankfurt. Is this the only production site?
Yes, it is. Yes, it is. All CDS products are developed and produced in our plant in Sprendlingen, which is pretty much in the middle of Germany.
Yeah, okay.
Yes. They are subject to permanent quality control and to the inspection of the TÜV Germany. German Association for Technical Inspection. They are, according to CE labeling, compliant to national and international regulations like FAA. One can really say CDS products are made in Germany.
Okay, okay. Let me come to another point. So when I see that our material is on the market for such a long time, I'm sure there are a lot of references, right?
Yes, you can bet on it.
Okay.
Material has been used for more than 60 years on military and civil airports around the world.
Okay.
So we have a lot of references, and we have a reference list with airports from Abu Dhabi to New Zealand. In Central Europe, material has been used or is used in nearly every major airport. In Germany, of course, but also in France, in Spain, in Greece, in Portugal. I could name
nearly all over the world.
All over the world, and also in Asia, in Africa, and in South America.
Okay, and so in very different, let me say, types of climatics, right?
Yes.
Okay. So have you some examples on recent projects for us?
Yes, recent projects are just carried out in Southeast Asia, in Southern Europe, and in Africa.
Okay. So thank you, Martin, for your explanations about CDS and airports. And thank you all for watching us this time.
See you at the airport.
Goodbye.
Goodbye.